Students, in our previous video we have seen how the current flows as the product of charge movement. As charges move from one atom into another atom, the charges are circulating now and then the current flows in the opposite direction to the charges movement, isn't it? So when we supply when we supply some source of voltage, or we supply some force of attraction to the charges, then the charges will experience that attraction or force of attraction and they start moving from one atom onto another atom. Likewise, charges are circulating from one atom to another atom, and we have that charge just moving continuously. That continuous flow of charges will make the current to flow, and current always flows in a closed loop. There should not be any cut in between. So there should be a continuous path. That is called as what? Closed loop or closed circuit. We will call it as. Circuit is nothing but what? It is the interconnection of all the circuit components and your voltage sources. You may have the load. Load means what? The device which is getting the current and it is getting operated. That's all. Okay. So this is all we have about the current and voltage, and we will see the current and voltage in detail in today's class. So here what we will see is, so we have considered the charge, isn't it? So we have charge. We have already seen the properties of charges, isn't it? So charges properties in previous class also we have seen some of the things about how the attraction is going to happen. So charges, like charges repel each other, unlike charges attract each other, isn't it? Like charges repel each other, unlike charges attract each other. And what is the next thing? Charges can't be created, they can't be destroyed, isn't it? So they can be only conserved. Okay, so we can change. So what we can say? The charges can't be destroyed, or we can't create charges. They can only be conserved. And next thing is, so if I take a conductor wire, if I take, so I can see the charges which will be moving on the outer layer only. Okay, not in the inner part of the conductor. Okay, so on the outer layer of the conductor we can see the charges which are moving. Okay, so and then next point what I can say about charge is never affected, or the magnitude, or we can say strength of the charge, or what we can say that's the magnitude of the charge, or charge is never affected by motion. We can say so and so. Charge is never affected by motion. If the charge moves from one atom to another atom, it is not going to affect anything with its strength, or we can say the charge capability. So this is how we can say about charge is never affected by motion. And next thing what I can say is the what we can say magnitude of the charge. So magnitude of the charge can be said as, so we can say about magnitude of the charge on a single electron. So electron we will be denoting it as what? Minus E. So minus E means what? Electron, or the same charge will be present on your proton also, isn't it? So electron is a positively charged particle. Your proton is what? Electron is negatively charged particle, and proton is what? Positively charged particle, isn't it? So proton and electrons will have same magnitude of charge, only there is change in the sign, isn't it? So it is positively, like electrons are negatively charged particles and protons are what? Positively charged particles having same magnitude. So magnitude of charge on a single electron. So single electron is denoted as minus E, and proton is denoted as what? Plus E. So electron is minus E, will say, and the proton as what? Plus E. So magnitude of charge on single electron or single proton is what? It is 1.60 60218 into 10 power minus 19 C, that is what? Coulombs. Okay, so SI unit, of charge is what? Coulomb. So Coulomb is the name of the scientist. He is a French physicist who measured the force between the charges, and his name has been given as a unit for the charge. So 1.602 or 18 into 10 power minus 19 coulombs. C is the denoting alphabet what we will be using. So it is denoted as C. And what is the unit? SI unit is what? Of charge is what? Coulombs. Okay, so it is denoted as what? C. So SI unit, standard international. SI unit what is? Standard international. So this unit is what? Accepted throughout globe, isn't it? So internationally it is accepted. So if it is if I say, for example, if I go for an electron, or if I go for 1 coulomb of charge, if I say, so then this 1 coulomb will be same here and same in other countries too. Okay, so that is what SI unit. All are following the same unit or same point, like what we can say, same what we can say is same amount or same what we can say, if here in some of the things what we can say for weight here, like we will weigh in what? Kgs, isn't it? In some of the countries they will use pounds and all, isn't it? So that is the change in the units what we can say. So previous and all, like they used to weigh using pounds and all, isn't it? So nowadays like it has been made as what? Kg. So kilograms will be the actual weight of or any of the thing we can weigh with kg. Kilogram is the SI unit or standard unit what we can say it as. So likewise charge or magnet of the charge is said in what? Coulombs. Okay. So this is the charge. 1.60218 into 10 power minus 19 coulombs is the charge on or the strength of the or magnet of the charge on one electron or one proton. So now it can, like if I say for electron, it is what? Minus 1.602 into 10 power minus 19 coulombs, and this is for proton, then I can say it is what? Plus 1.602 into 10 power minus 19 coulombs. 10 power minus 19 means what? This fraction or this decimal point goes towards what? This direction it will be going, isn't it? So if I say something like, for example, if I say 0.1, if I say or 1.25 into 10 power minus 3, if I say, how will you write this? If it is 1.25 into 10 power minus 3, if it is, so if some value, if I have given, so for example I have given a value, so how will you write it? What is this? The power is given if we have lot many of fraction. If I have lot of fractions, or if I have lot of zeros followed by some number, if I have so many zeros, so then we will be going for this multipliers to or for the proper representation of a number. So if I use multiplier, I will be reduced with the writing of so many digits, isn't it? So that is why I will be using these multipliers to simplify the presentation. Okay. Yes. So now if I have written so and so what is the actual number? What is the actual number? If it is 10 power minus 3, 10 power minus 3 means what? So I have to multiply this, isn't it? I have to multiply this with this. So then I will be getting the thing, isn't it? Yes. So what is that? Minus 3 means what? What is minus 3? What is minus 3? Minus 3 means what? It is so this decimal point will be shifted 3 times towards this direction, isn't it? Minus 3 means the decimal point will be shifted this direction. Plus means what? The decimal point will be shifted in the right hand side direction. It is left hand side direction. We have to go for minus 3, isn't it? So in a graph, you know that, isn't it? If in a graph, so this side if I go, all this side it is all negative values in this direction, isn't it? For your x-axis, isn't it? So for a graph, right? So these all are the general things you are aware of, isn't it? Yes. Now, if I go for this value, what will be the value here? What will be the value? So I should go 3 times this direction, isn't it? So it is what? 1, 2, 3. So I should fill it in what? Zeros, and here comes the decimal point. So what is the actual value? It is 0.00125 is the value. So instead of writing all these things, I have written it as what? 1.25 to 10 power minus 3. Isn't it? Correct or not? Fine. So this is how I will be going for. So decimal point should be shifted 3 times. Once, second times, and third times. So the actual value is what? 0.00125. Okay. So if it is plus, if I give some value which is plus, it is 1.25 into 10 power 3. If it is so and so, so I should make this decimal point to go towards what? This right hand side direction, isn't it? I should go positive. Okay, so it is nothing but 1.25. 3 times I should go further. 1, 2, 3. Isn't it? So I will be adding a 0 here. So here comes the decimal point. So the value is what now? It is 1000/50 is the value if it is plus 3. Okay, so this is how to make out the values, and multipliers will use for simplification. Here it is 10 power minus 19 means after this, like after this decimal point should be shifted 19 times to left, then I will be getting a value so much of zeros. Okay, so to simplify that, I have taken we will be representing the value so and so. It is 1.60218 into 10 power minus 19 coulomb. So much small fraction of a coulomb. Okay, if I say for 1 coulomb, so much small fraction will be the charge carried by 1 electron or 1 proton. Okay, yes. So SI unit is what? Coulomb. And if n electrons, if n electrons pass through a cross section of a conductor, if I have a conductor wire like this, cross section is what? The cut portion. Cross section. If I cut that wire somewhere here in between, so this will be the cross section of the conductor wire F. Okay, so if n electrons, if in this cross section of the conductor n electrons flows, n number of electrons, n is what? Number of electrons. If n number of electrons pass through a cross section of a conductor in time t, so in time t seconds. Time is always said in what? Seconds, right? So in time t second, if n number of electrons pass through a cross section of a conductor, so then total charge passed, or the total charge passed, if n number of electrons pass through a cross section of a conductor in time t, then I can say the total charge or total amount of charge which is passed through this cross section area of a conductor is given as what? Total charge. Charge is denoted as what? Q. Charge will be denoted as what? Q will denote it as we use C for coulombs, isn't it? To indicate the unit, we use the alphabet or capital letter C, and for charge we will use the alphabet Q. So let us charge is denoted as what? Q. So the total charge passed is Q will be equal to what? N into E. So N is the number of electrons and E is what? The charge of 1 electron. So charge of 1 electron into number of electrons will give you the total charge which will be passed through this cross section area of a conductor in that particular time or t seconds of time. So this is how I can say the total charge. Charge is only like the number of electrons multiplied by charge carried by one electron will give you the total charge. That's all. Okay. So now, if like I will be seeing, we will be seeing how I can measure. If I say 1 coulomb of charge, if I say 1 coulomb or 1 coulomb of charge, if I say, okay, so if I say 1 coulomb of charge, so how many electrons will make 1 coulomb of charge? So that is my question. So how we can pick out that? How we can pick out that? So charge on 1 electron is what? Charge on 1 electron's charge is what? It is 1.60218 into 10 power minus 19 coulombs, isn't it? So that is the charge carried by 1 electron. Okay, so if I have to calculate how many electrons will make 1 coulomb of charge, how many electrons together will make 1 coulomb of charge. So this is so much minus times of the coulomb, isn't it? So this is how I will be calculating. How I will calculate? So charge carried by or magnitude of the charge is what? 1.60218 into 10 power minus 19 coulombs is the charge carried by 1 electron. So to calculate the number of electrons which will be present in 1 coulomb of charge, what I have to do is, it is 1 divided by 1.60218 into 10 power minus 19. If I do, then I will be getting 1 coulomb of charge, isn't it? So this much of charge in 1 electron. So 1 coulomb of charge will, or 1 coulomb will have how many electrons? So this is how I can calculate. 1 divided by the charge carried by 1 electron. So if I do that, it will be 6.25 into 10 power 18 electrons into 10 power plus 18. Okay, electrons. Okay, fine. So if I have to calculate for 1 coulomb of charge, how many electrons there will be? So that will be 1 divided by the charge of or magnitude of the 1 electron. So this is how I will be getting the result as it is 6.25 into 10 power 18 electrons. If I have 6.25 into 10 power plus 18 electrons, so many electrons come together, so then I can make 1 coulomb of charge. Okay, so charge 1 coulomb is what? It's a huge unit. Okay, so it's a huge unit. So 1 electron carries so much small amount of charge that of 1 coulomb. So to calculate 1 coulomb of charge contains how many electrons, I should do this calculation, so that I will be getting the result as what? 6.25 into 10 power 18 electrons will make 1 coulomb of charge. Fine? Yes. Now coming to electric current. So what is electric current? Electric current is nothing but, what is electric current? Electric current is nothing but the flow of charges, isn't it? So continuous flow of charges is nothing but your electric current. It is the product of flow of charges. So the strength of electric current, what I can say is, so electric current is denoted by what? I. So we have seen this, isn't it? Yes. So the strength of electric current is defined as, the rate of flow of charge. So what is that? The rate of flow of charge. This rate of flow means what? The rate of flow means what? It is with respect to time. So rate of flow means what? Which will be with respect to what? Time. To the base of time. Okay. In what amount of time, how many charges are moving? In what amount of time, how many charges are moving through a cross section of a conductor? So that will give you the strength of current. Fine? Is that okay? So rate of flow is what? With respect to time. At what time? At what time? How many things or how many charges are moving? So strength of electric current is defined as the rate of flow of charge through a cross section of a conductor. So that will give you the strength of electric current. So that will give you a strength of electric current. Okay. So that is the word. At what time, how many charges are moving? That will decide you what is your current strength, or what we that particular cross section area of a conductor, we can say it as. So if Q is the amount of charge, or if Q is the amount of charge or total charge, so what is Q? Q is N into E, number of electrons into charge of one electron. So that is the total charge. So now if Q is the amount of charge flowing through a cross section of a conductor in time t, so then I can write current as what? Current will be equal to charge divided by time. So current will be equal to what? Charge divided by time. This is how I can write so much charges, or so much amount of charge is moving in so much of time. So this is how I can define current. So current is equal to what? Charge divided by time. So that is I will be equal to what? Q by T, I can write it as. So I will be equal to what? Q by T. So total charge moving in how much amount of time? Okay, with respect to time, that is nothing but your rate of flow of charge. So that is with respect to time. So I will be equal to Q by T. So I can write Q as what? N into E divided by T. Isn't it? Fine. So this is how I can go for the electric current. Okay. So electric current I can write so and so, and the unit. So SI unit of electric current is what? SI unit of electric current is what? Ampere. Ampere is the SI unit of electric current. Current is measured in what? Amperes. So denoted by letter A. Okay, capital letter A will denote it as so current. Okay, usual units or usual unit for your current will be milliamperes, amperes, microamperes. Okay, so 1 ampere is what? It is a huge unit for your electric current. So it is represented as what? Ampere. Okay, so ampere is the SI unit of what? Current. SI unit of current. SI unit of current is what? Ampere. And if I will be going for measurement of 1 ampere of current. 1 ampere of current. How I can define 1 ampere of current? 1 ampere of current. How I can say? As we have said, 1 coulomb of charge, isn't it? So likewise, I will be going for 1 ampere of current. 1 ampere of current, I can say. How I can say 1 ampere of current which is flowing through a conductor? So if I have to say that if 1 ampere of current, if some current is 1 ampere, then how I can say it as this? So if 1 coulomb of charge, is flowing through a cross section area of a conductor, so what I can say is 1 ampere of current is measured when 1 coulomb of charge is flowing through a conductor in time t. Okay, so in what I can say is what? 1 second. Okay, so if what is 1 ampere of current? If 1 coulomb of charge is flowing per 1 second, or what we can say, if in 1 second of time, if 1 coulomb of charge is flowing through a conductor, then I can measure that current as what? 1 ampere. Okay, so 1 coulomb of charge should flow. That means what? How much electron should flow through a cross section area of a conductor in 1 second? In 1 second, through a cross section area of a conductor, how many electrons should flow? What is 1 coulomb? 1 coulomb is nothing but 6.25 into 10 power 18 electrons, isn't it? Correct or not? So 6.25 to 10 power 18 electron should flow in 1 second through a cross section area of a conductor. So then I can measure, then I can say the charge flow through that cross section of a conductor in 1 second is what? 1 coulomb. So then I can measure using a meter over there, I can measure how much of current, 1 ampere of current I can measure. So this is how I will be defining 1 ampere of current. So SI unit of your current is what? Ampere. So 1 ampere is nothing but 1 coulomb per 1 second. If in 1 second 1 coulomb of charge flows through a conductor, then I can say it as what? 1 ampere of current. Okay. Yes. So a cross section of a conductor in the sense, if I have a conductor wire at certain point I will be considering. Okay. At this point I will be measuring, or not this point. I can go for another point. So in all the points it will be showing you the same current which will be flowing. Okay. Fine. So this is how I will be going for 1 ampere of current. Okay. Fine. Yes. And now here, if dq is small amount of charge flowing, if I say for some small change, okay, so dq, if I have to say if there is some small amount of charge, if I have some small amount of charge, some change in the charge, so then charge flowing in a small change of time. So if this amount of time, okay, if I have some small change in the time dt, if I have small change in the time dt, so I can write in that particular small change in time. So if this is the charge which is moving or flowing, so then I can write the current. So I can write the current I as what? So current can also be denoted using small letter I also. So then I can write this current as I is equal to dq by dt. So at this dt means what? It is small change in the time. Okay, so dt is what? The small change in the time. In this small change in the time, if this small amount of charge, dq is the small amount of charge which is flowing in small change in time dt. So then I can say the current I as what? Dq by dt. So this is how I can go for the current representation, and people are aware of that current always flows from, if I have positive and negative potential or voltage source or EMF source, voltage source or EMF source, if I have, so the current which is flowing through a load will be from where to where? There should be a closed path, isn't it? There should be a closed path. In this closed path, current will flow from positive of the battery towards negative of the battery. This is the conventional flow of current. Conventional flow of current is from positive terminal of the battery towards negative terminal of the battery. So this is the direction of conventional current. Okay. So current always flows in the opposite direction, that of electron movement. Okay. So charges are what? Here electrons are the charges which are moving from electrons are the charges which are moving from negative of the battery towards the positive of the battery. Suppose electrons will experience a force of attraction towards what? Positive of the battery. So the charges has to circulate from negative of the battery towards what? The positive of the battery, and they will go into the positive of the battery, and they will be again shifted to negative of the battery, and they will be pushed. Okay, so this is how the circulation, continuous flow of charges is happening. So this continuous flow of charges is called as what? In the other direction it is called as what? Current. Okay, so we can say the charges are moving, so that movement of charges we will be calling it as what? Electric current. So current always flows from positive of the battery towards negative of the battery, and current always flows in a closed circuit or closed loop, we can say. Okay, so this is how I will be going for if small change of current or a small change of time, small amount of charge is flowing, then I can write current I as what dq by dt, and the direction of conventional current is always from positive of the battery towards what? Negative of the battery. Okay, so after all this, so we will be coming to the potential difference. We will be coming to the potential difference or the EMF or voltage applied. Okay, so without this current never flows, isn't it? Fine. Yes. So we have potential difference V. So potential difference or voltage, we will call it as potential difference. What is that? Difference in the potential. What is that? Difference in the potential. That is what is the potential difference. It is denoted by what? V. It is denoted by what? V. So the amount of work done. How we can define potential difference as? So the amount of work done in moving a unit charge. So we have a unit charge for one charge here. Okay, a unit charge is there. So if I have some electron, if I have one electron over there, so what is the potential difference? What is the potential difference? The amount of work done. So how much of work you are doing? How much of work you are doing in moving, or you are means what? With the application of voltage source. Okay, so this will do. We need not do. Okay, we have to only apply. Okay, so what is the potential difference? How we can define this is the amount of work done in moving a unit charge. In moving a unit charge. Okay, in moving a unit charge from one point to another point in a circuit. Okay, from one point to another point in a closed circuit. Okay, so the circuit should be closed. Otherwise, there is no movement of charges. Fine. Is that okay? Yes. So it is the amount of work done in moving a unit charge from one point to the other point in a closed circuit. Okay, in a closed circuit, if that is the thing, so then that we can define that as what? Potential difference. So that is the potential difference between this point and this point. The difference in the potential between 2 points is said as what? The amount of work done in moving a unit charge from this point to the next point. Okay, so that is the difference in the potential. Okay, so this is how I will be telling it as. So potential difference between 2 points is given by, that is equal to, potential difference is equal to what? Work done divided by charges transferred. So how much of work you are doing and how much charges are moved, or how much charges will be transferred. So how much work you are doing divided by how much amount of charges you are transferring. Okay, so that will give you what? The potential difference between 2 points. Okay, so SI unit for your potential difference is what? Volt. SI unit for potential difference is what? Volt. And when I say 1 volt of voltage, if I have to say for 1 volts of potential difference or 1 volts of voltage, if I have to say, so then how I can define 1 volts of voltage is, it is 1 joule of work done in moving 1 coulomb of charge. Then I can measure 1 volts of voltage or 1 volts of potential difference when 1 joule of work is done. When 1 joule of work is done in moving 1 coulomb of charge. In moving 1 coulomb of charge from one point to the other point, if 1 joules of work is 1 joule of work is done, so then I can say that potential difference between 2 points is what? 1 volt. I can say it as. Okay, so difference in the potential is nothing but your potential difference between 2 points. So this is how I can say, or I can define the potential difference. SI unit is what? Volt. It is denoted as what? V. Capital V. Will be using small v also, you will be using sometimes. Okay, so this is how we will be going for the potential difference between 2 points. It is nothing but your EMF, electromotive force, which will be applied. So this is how we will be going for the potential difference. And what all things we have seen? So we have seen the charges, and we have seen the electric current, and then we have seen the potential difference also. So this is how we have the different things which will be coming into picture, and after that about AC and DC current. We have discussed it earlier once. So again, in our next video, we will be seeing what is your alternating current, what is your direct current, and we will see the differences between AC and DC. All those things we will continue with